Today I'm going to talk about what a self-contained system is. It's a system that has a boundary. And so sometimes the boundary for a system is a surface or a manifold, such as the skin for the apple. And so one of the things that's interesting about that is that in set theory and mathematics, you can have self-contained systems which are four-dimensional. So they move in time and space, and they take up an XYZ plane, the projective plane. So with those three vectors, you can think of how apples are closed systems. An apple is a system. Anything is a system, and but they're closed, or not a closed system, but a closed set. And there's a difference between a closed system and a closed set, because nothing is technically a closed system except the universe itself. The thing about cosmology is that if the universe is not a closed system, what would happen is it would cause the conservation of mass and matter to the basic laws of conservation in chemistry and information theory to either to basically not hold true in all instances. But the thing about a self-contained set in four dimensions, is that it really, or in three dimensions, it doesn't really, how do I put this, apply to thermodynamic systems, because all thermodynamic systems that are operated locally are open systems as far as we know. So the air, we obviously can't see, but there is the surface of the apple has a limit, and the air actually merges with that limit, but in a different way. So like a good example of how we could show a little easier how open an apple is if we cut it in half. And so you would have oxidation, and just like when we form blood clots as humans, the oxidation would cause a browning effect. And so the thing that's interesting about that is that decay is constantly happening as the environment is abrasive to the apple. And as the apple itself decays, time is involved in that, as well as chemical interactions and physical interactions with the outside environment, the air. And so one of the things about self-contained sets is that we can imagine a self-contained set when talking about set theory, but we can't apply a self-contained set as a pure measure or a close enough measure without a correction factor that would have to be so extreme at a maximum that it doesn't exist. And so all thermodynamic systems are always open, like I said, if they're local, but not if they're general. So the only really general thermodynamic system that is actually closed is the universe, and that's because we can balance out chemical equations. And so, yeah.